Hi there. I decided to make this dimensional analysis tutorial for those of you who are having trouble with dimensional analysis, just so you can practice at home. First thing you got to think about is, why are we doing this? A lot of these first problems you could probably figure out how to do just in your calculator or maybe even in your head. But we have to get down the process and how to set it up this way, because later on the problem is going to be much more complex, and we want to make sure that we have a way to set up a multi-step problem so we don't get confused with units and we always get the right answer. So even if you can get the right answer now without it, I really suggest that you focus and figure out how to set it up this way so that you can set up the harder problems later on. Here's an example. Let's say in class we burn peanuts. Right? When we burn peanuts, they give off energy. If we measure that energy, let's say we find out how many kilojoules of energy are given off per gram of peanut that we light on fire. And we want to convert that into our food calories, to compare it to how many food calories you would get out of the peanut. Well, we would burn it and we would measure the kilojoules, because that's how we measure energy in class. So then we would have the question, if the peanut gives us 25.0 kilojoules per gram, how many food calories is that per gram? Whether it's a word problem or not, you want to narrow it down, figure out what they're giving you and what you're looking for. So now we need something to connect kilojoules to food calories. And that's where we look for an equivalent statement. And you don't have to memorize these. We can get these out of our book, or I'll give you the equivalent statement you need. You just need to know how to use it. So here's our equivalent statement. 1 food calorie, we're going to abbreviate that capital CAL, equals 4.184 kilojoules. So we're going to use KJ to symbolize kilojoules. So now we have this mathematical expression where 2.50 kilojoules equals blank food calories. Right? And now we're going to use that equivalent statement in the blue and red to convert from kilojoules to food calories. When we do a conversion, we're always going to start with the given. So here is my given, my 25.0 kilojoules. It never goes in this fraction. It's always before the fraction. And then I'm going to times and a blank fraction line. That's how I start every single one of these problems. Now the idea is I want to get rid of kilojoules, and I want to replace it and end up with calories. So to do that in a fraction, where would I put kilojoules? Would I put it on the top or on the bottom? Mathematically, I have to put the kilojoules on the bottom so that they will cancel each other out. So I'm taking the kilojoules from the equivalent statement and I'm putting it on the bottom of this fraction. This fraction is called a conversion factor. Right? That way my kilojoules are going to cancel out. The other part of the equivalent statement, right, what I'm looking for in this case, is going to go on top of the fraction, because that's what I want to end up with. So now I have 25 kilojoules times 1 calorie divided by 4.184 kilojoules. And this is going to do my conversion for me. This way I never make the mistake. I know for sure I have to divide by kilojoules. So I'll never make the mistake of accidentally multiplying by kilojoules. And my units cancel, I end up with just calories, and that's what I want. So now I'm ready to finish up my problem. Kilojoules are canceled. All I have to do is take my 25.0 times 1 food calorie. Right? I usually hit equals at this point in my calculator before I divide. It's not always going to be 1. Sometimes it'll be another number, but in this case it is just 1. So 25.0 times 1 equals, and then divide that answer by 4.184. And I get 5.9751434 food calories. So when I burned my gram of peanut and got 25.0 kilojoules, that's the same as 5.97, or almost 6 food calories. So now I figured out how many food calories came out of that peanut. And that's what I was looking for. Since my units match what I was looking for, I know I'm done, and everything else canceled, so I'm good to go. Now a couple things to note. On this conversion factor here, right, the only reason we can make this is because of this equivalent statement. It's always made from an equivalent statement. If this side, the blue side, equals the red side, then the fraction is really the same on the top as it is on the bottom. That's the only reason why we can do this. 25.0 kilojoules is the exact same as 5.9751434 food calories. This conversion factor just changes units. It doesn't actually change the value. 25.0 kilojoules is 5.9751434 food calories. They are the same amount, just measured in different units. So it's kind of like multiplying by 1 with the purpose of changing the units. So we have to use the numbers from the equivalent statement. I could never change these numbers, right? Wherever calorie is in the conversion factor, whether it's top or bottom, it's always going to have the number 1 with it if I'm using this equivalent statement. And wherever kilojoules is in this fraction, it's always going to have 4.184 with it, okay? That's the only way that this conversion factor works. Now, we've also learned about significant figures. So while we've got this answer, we might as well round it to significant figures. A couple of things to note. This math process, multiplication, has a specific rule for significant figures. We count significant figures. Our given has 1, 2, and 3 significant figures, right? We do not worry about the conversion factors. These are considered to be infinite significant figures or exact numbers. So we only worry about the given here. So this has 3 significant figures, so my answer should end up with 3 significant figures. Well, I got 1 significant figure in the 5, another one in the 9, another one in the 7. So those are my 3 numbers. But now look at the 5 after the 7. 5 is big enough to make the 7 round up. So when I sig fig this answer, it becomes 5.98 food calories because that 5 is knocking the 7 up to a higher number. If this was a 3 or a 4, it would stay as 5.97. So that is my final answer. I matched it to my given, checking my significant figures, and I'm done. So 25.0 kilojoules coming out of my gram of peanut is equal to 5.98 food calories. And that's how you're going to do all your dimensional analysis problems. When I check these, I am going to check that in your work, and this part I'm circling with the cursor right now, that is your work, right? You've got the given with its unit. Do not forget the unit. It's really important that we keep track. And this conversion factor with both units, and then your answer with units. And on this first assignment, I'm asking you to round to sig figs, okay? But I'm going to check this answer for credit, and then we're rounding to sig figs for practice. All right, so go ahead and finish up those dimensional analysis problems, and hopefully you're all set. If not, come in and see me and we can go through some more. Have a great day.